So I'm Johan, working at the Elia Group in the Strategy and Innovation team, and I'm here with Guillaume, working in inside company, doing AI, artificial intelligence. We're going to present you today one of our use cases in artificial intelligence that we applied in the utility sector, based on one of our projects called IO Energy. So IO Energy is a project we have launched in Belgium with the TSO and the DSO as a consortium. On this picture, you can see that in 13 years apart, we evaluate from horse riding toward vehicle riding in New York. This happened in only 13 years in the blink of an eye. And this is basically our approach to anticipate and adapt ourselves to ensure that our mission as a system operator remains in the future. Last year, in November 2018, we released a paper about the consumer-centric vision. And we have a vision that where we would like to place back the consumer at the center of the electrical system. The energy transition is making that we are moving from an epicentric production of energy toward a more decentralized and a prosumer-centric energy system. As a response to this evolution of the energy transition, Elia is working on, we call it 3 building blocks. The first one is to upgrade the market design. The second one is to work on a real-time communication platform. The last one is to work on the digital tools that will enable all this to work together. I will present quickly the IO Energy, which is the communication platform, and the 2 others will be, well, we're working on the 2 others via use cases, and one of them we will present it just afterwards. Basically, the approach from this real-time communication platform is we base it on an open data approach, where we give the consumer the full ownership of its data. So what we're building there, it's a communication layer that will connect the people that has a service to provide to the community and to the consumer with the consumer that have data and want to have new services available. As the previous speaker said, we have to focus on the added value for the consumer, not on how to change their behavior, but really what it brings to the end consumers. We have developed this together with the TSO and the DSO in Belgium. We have 60+ companies taking part of this ecosystem, and together we are creating their MVPs, use cases, that we could port toward the market in the future. And we're doing this in a stepwise approach, starting from a sandboxing phase that is right now ongoing with this platform. Next year, we're going to scale up until a demonstration phase, and then the year after, the idea is to go for industrialization for the different use cases. Okay, now I will deep dive into Check My Flex, which is one of the 8 use cases selected for this platform. We are in Paris, and you know that a few years ago society has put big goals into place, where we want to limit the amount of increased degree of the world by 1.5 degree maximum. It's an objective, and this objective has basically a huge impact on us as citizens, because basically we want to ensure a nice future for the future generation, but you also don't want to have a huge impact on our consumption bills and our comfort level. It also has an impact on the system operators, because basically the network was not designed for such a change as the energy transition. The network was designed to evacuate power produced on a big central production, and now we're moving towards something that is more decentralized, and we have to make the network evolving. Even though the system operators, they want to support the energy transition and the society as a whole with its big objective. So our idea is to put in place Check My Flex. Check My Flex is basically a smart box that we're installing at your home, and that will automatically control your devices, heaters, boilers, electrical vehicle batteries, according to a comfort level that you have put in place, and it will respond to a price signal in order to get you a reward. So basically, you are rewarded to participate in this system. This is it into more drawing, let's say. So basically, on your left side, we are defining the system needs. So from the DSO or the TSO, imbalance, congestion, local community, etc. Then via an artificial intelligence, we're transforming those needs into a price signal that is sent via the IO energy platform toward the end users, and the smart gateway there will listen to those price signals and react to those automatically based on your comfort settings. A reaction is then sent back to the artificial intelligence to adapt the price signals according to the new needs of the grid, the new condition. As I mentioned, well, basically you can see it as a new way to see the day and night tariff, but more real-time tariff. As I mentioned, we are not doing that alone. We have created a huge ecosystem of partners. And in this project, we are working with the different partners that you see here on the slides. Now, Guillaume will deep dive into more details of the artificial intelligence part.
Thank you, Johan. So let's deep dive into how do we generate this smart pricing signal depending on the use case. So here we applied this box. It all starts with a need. So as a TSO, for instance here, what we did in the past already is to apply it to the case of real-time balancing. So as a TSO, you want to minimize the residual system imbalance. And so here, the use case need is to minimize these needs. Of course, this approach could be used, smart pricing, for other needs. Could be used, as Johan mentioned, for congestion management, for TSOs, DSOs, but also for balancing of a BRP portfolio, or even for local energy communities to incentivize the auto consumption. So, starting from your need, if you consider balancing, first you have to forecast what's your system imbalance is going to be in the future. Then it is used as an input to the smart pricing module, and then that's where the AI comes into play, or more, let's say, machine learning. And based on the needs and other signals, it will generate a price signal which is broadcasted to everyone. Then, second step, the end consumers, the residential consumers typically. So they receive this price. I mean, not them, but the smart boxes installed in their homes, because we don't want them as a customer experience to deal with that in everyday life. It's more the smart box who will react, but it will react only if it does not put into danger the comfort of the end user. So the price signal is an input to this smart box, but of course, sometimes it will not react because you want to have hot water anytime, or you want to charge your EVs anyway, whatever the price signal. And then third step, you have, as a system operator or as use case needs, let's say, it's good to have some view on what's happening. So of course you can have some very aggregated feedback of what's happening. You could also consider to have very detailed feedback coming up from these small residential levels, and that closes the loop. And of course, based on this feedback, the AI intelligence will update the pricing signals to do better next time, basically. And so why is it difficult? So here I show a picture where you see the price that you push, that you export the customer to, and you see here 3 typical curves. So one, for instance, which is how people would react to a given price at 7 in the morning, at 6 in the morning, or at 8 in the morning. It's just an example showing you that it's not so easy to decide on the price, because you push a given price, maybe, I don't know, 50 euros per megawatt hour, and you can see here that at 6, 7, or 8, the market reaction, the aggregated one, will be very different. So the AI intelligence really needs to take that into account to push the right price signals. Maybe taking into account as a feature the hour of the day. And so that's one of the key challenge here. So what we do to solve that is that we, of course, used the past prices published. We consider we in steady state. We have also the market reaction, the desired market reaction. So here we have the forecast of the system imbalance. We want to get rid of it. And we see what mistakes we have done in the past. And on top of that, we use a bunch of other system features for balancing, like load forecast, solar forecast, wind forecast, and so on. Temperature, but for other use cases, you could use other type of signals. And combining that and using machine learning algorithm based on reinforcement learning and supervised learning, then we are able to compute a price which is not perfect, but quite good anyway, as it can be illustrated here. So in blue you see the optimal price. I'm not going into the details of how it is computed, but that's the ideal price if you knew the world perfectly. And you see in orange the curve, the price that is computed by the smart pricing module, and you see that it's quite close to what it should do ideally. So not knowing how the real world behaves. So we can do things with smart pricing and apply it in different use cases. So what are the next steps here? So as Johan mentioned, so we are now in this sandboxing phase of the IO Energy initiative in Belgium. And so early October, we started this initiative with the consortium partners. And now we are testing these price signals with electrical boilers with real consumers. And so in a couple of months, so end of March, we'll have a first, let's say, validation also, technical validation, so testing how does it work in practice, but also, and it was not the focus here, but what about the customer experience and so on. That's also, of course, very important if later we want to build a business case. So just for you to remember that using machine learning, it's possible to develop useful technologies also for the world of DSOs, TSOs, and other actors in the energy domain. And if you want to know more, don't hesitate to talk afterwards with Johan or myself. And for Inside, we have a booth here, so feel free to come in the next couple of days to talk about this with any of us. Thank you.
Thank you very much. Any immediate questions from the audience? We have, again, one time. No? Well, since Johan is also part of our panel in the afternoon, I think we can focus on the questions then until the end. But thank you very much for your time, and good luck with the project.